Hi everyone. In today's video, we're going to explore the various types of variables and enumerations used in C# with simple, clear examples. So let's dive in and get started. In C#, variables are used to store data, but depending on where and how you declare them, they behave differently. There are mainly 5 types of variables in C#, which are local, instance, constant, static, and read-only variables. First, we learn about local variable. Local variables are declared inside methods and only exist within that method or block. Once the method finishes running, the variable is gone. In this example, name is a local variable used inside the method. It's temporary and cannot be accessed outside this method. Next is instance variable. Instance variables are declared inside a class, but outside any method or constructor. They are also known as non-static fields. Each object created from the class gets its own separate copy of the instance variable. They are used to store data that is specific to each individual object. For example, if you have a person class with a name variable, each person object can store a different name like Elise and Bob. Let's understand by example. We have a class called person with an instance variable named name. When we create 2 person objects, one for Elise and one for Bob, each object stores its own value for name. So when we call showName, on each object, they print different results. Elise object prints name Elise, and Bob's object prints name Bob. That's the power of instance variables. They hold data unique to each object. Next, constant variable. A constant variable holds a value that never changes. It must be assigned at the time of declaration and cannot be modified later. Constants are always static, even if we don't explicitly write static. Let's look at an example. Here, we have a constant called pi, and it's set to 3.14. Since pi is a constant, its value is locked in and can't be changed later. We use this pi to find the area of a circle with radius 2. When we multiply pi by 2 times 2, we get the area. Because pi is a constant, the computer knows its value when the program is built, so it's super fast and never changes. Easy, right? And here's the result. The area of the circle is 12.56, calculated using our constant pi and a radius of 2. Simple, accurate, and efficient. Next, we look at the static variable type. It's important because it behaves differently from regular variables. A static member belongs to the class, not an object. This means it is tied to the class itself and exists even if no objects of the class are created. It is shared across all instances of that class. All objects access the same static member, so changes made by one object are visible to all others. Static members often track common values, such as the number of objects created. This helps in managing data that is relevant to the class as a whole rather than any single object. In this example, we have a static variable called counter. It starts at 0. Every time the method add is called, counter increases by 1. Since counter is static, its value is remembered between method calls. So the first call prints 1 and the second call prints 2. Last but not the least, read-only variable. Let's understand the key points about a read-only variable. A read-only field is assigned either during declaration or within the constructor. Its value cannot be changed once it has been set. It allows values to be assigned at runtime, unlike constants. A read-only field is assigned either during declaration or within the constructor. Let's see. In this example, we use a read-only variable named number. We assign its value inside the constructor, and after that, it cannot be changed. Read-only is useful when you want to allow one-time assignment, often using values known only at runtime. Now let's look at enumerations in C#, also known as enums. In C#, an enum or enumeration is a way to create a group of named values. It's useful when you want a variable to only have a few specific options, like the days of the week or traffic light colors. Each name in the enum is linked to a number behind the scenes, starting from 0 by default. Enums make your code easier to read and help avoid using random numbers or strings. In this example, we've created an enum called day with the days of the week as named values. Then, inside the main method, we declare a variable called today and assign it the value day.monday. Finally, we print it to the console. The output will be today is Monday. This shows how enums can help make code more meaningful and readable by using names instead of numbers. Thank you for watching today's tutorial. If it was helpful, please like and subscribe for more C# content.